questions? Start Dylan. And here we go. So, welcome, ladies and gentlemen. We are looking at last night's homework. Question 4. We were talking about normal distribution. So, taking a look at this. Let's see. Yep, here we go. It says, draw a curve that represents data which is not normally distributed. Distributed? Distributed. So, let's see. So data like this. Whoa.
Whoa, what? Whoa, no.
That would not be normal. There you go. Maybe I copied it off of you.
That's all you had to
Don't
do?
cheat. Very good.
That's all you had to do?
Yeah. Okay.
Are you kidding me?
Now, question 5. I didn't specifically use this word, but it might be one that you're familiar with.
Son of a...
Hey, gentlemen.
Bomb second.
Shh. No names, that said. So, name the percentile that describes a median. I don't know if you've ever had any sort of tests like SAT, or the size of my son's head, for instance, was in the 99th percentile. All right? Percentile means it is greater than all of the data below that point. All right, so we're talking about like a z-value, essentially. So the 50th percentile would be the point on your curve that has 50% of the data less than it represented. All right, so the median, being the highest point, 50% of the data is less than it. So that is the 50th percentile. Or my son's head being in the 99th percentile means his head was bigger than 99% of everyone.
Wait, so that's what... All you had to do was draw a line
Of his age bracket, anyway.
All you had to do was draw a line through the middle. Is that really it? Draw a line through the middle?
You didn't even have to do that.
So that's 922?
Nope, just any problem that's normally distributed. No? What's up?
This is 922. I actually did the first time.
Yep. So let's see. Other questions on this? What? Other questions?
About 7 or 8.
7 or 8?
8.
8?
7C.
All right, I'll start with 7, and then we'll see how far we can get.
Yeah, those are the ones written at me.
Those look good. I like them. And actually, I might even show you how to use... Well, I don't... We've got our table here. So, let's see. I got to grab my table out here. Get this ready. So let's see. Let's draw a picture. It's always a good idea. So, are you following along, friend? Problem 7. Do you have 7 out? You didn't do 7 right. Did you even do 7? No, doesn't look like it.
7. I did 7. I didn't do 8. That's why I said 7.
So, let's write this down. Make sure we get this right. So, let's see. It says set of 500 values. So that is referred to as n. We'll have that tie in today a little bit. Are normally distributed about a mean of 24. So 24 is our mean. It is also our median because it's the one with the highest frequency of occurrences. All right. And a standard deviation of 2. So 1 standard deviation away would be 26. 2 standard deviations would be 28. 1 standard less would be 22. 2 standards less would be 20. All right, so then they said what percent of the data is on the interval between 22 and 26? That is plus or minus 1. So that is, actually, let me snapshot. Let's see. Oh, I can't see my cursor when it's like that. Oh, I got it okay there. So let's see. So for part A, what do I know? I know that my t-value, it's a t-value because it's about the mean, is going to be 1 in that situation.
When is it?
When z-values are when it's like this and everything less than it. T-values are between 2 points. All right? So t-value of 1, so I would then look up my chart for when t is 1, and it's the classic 68.3%. Right?
68 point?
I don't need a snapshot, whatever. So P is 68.3%. And then if I asked, I could even say how many values are between those 2 points, and you could take 0.683 multiply by n and answer that question as well we wanted to. So let's see, 0.683 times
You don't have to, though.
500.
The
I know.
answer's-
We're going above and beyond, so that way you'll be ready for problems that would have asked that. That's all, friend.
What do you divide when you? I got a question. But it's not on this problem. But like, when you take like 22 and then you minus 25 and then you divide by something, what is that division thing?
I wasn't listening very well. Sorry.
Friend, come on.
I wasn't listening. I can show you. You guys can show me the homework later if you want.
Yes.
Well, you can put them in your folders for now. I see that they're done. You're good.
Also, should we try and do the homework that's due
You-
for tomorrow?
I'll have the video posted 4th period,
Oh,
so you can watch that.
so we're still have to do that?
If it'd be good.
Friend.
It might even be as good as donating your blood. Hey, look at on his shirt right there, the mountain. What's it say? Campaign Motel, something like that. Whatever. Well, look at that. That's a non-normally distributed curve right there. Would you look
Wait,
at
did you
that?
guys get community service for?
Don't worry about it. Don't worry about it. Let's focus on this. So, what I've got is what's up? So let's see. From 20.5. So 20.5 is right here. To 27. 27 is right there. So 27.5 is right there. So the question is, how many... Now, I'm thinking that a t-value would work well here because it's kind of a little range that we have. However, ladies, gentlemen, friends, please, going over this, right? Am I right? So I'm looking for a t-value. In order to find that, I'm going to have to figure out how many standard deviations away is this. And to do that, I want to figure out how many units is that. So 27.5, subtract the mean. That will give me the units, right?
Yeah, and then you divide by something. What do you divide by?
I divide by what a standard deviation is.
Which is what?
2 in this case, right? So this is, so what's that? 3.5 divided by 2. So this is 1.75 standard deviations, I believe.
So if the standard deviation was 5, you divide by 5.
Yes. I have a question.
Yes.
Oh my God! Why couldn't I
Can't
think
you-
of that?
Yeah, question?
Can't you just do 27.5 minus 20.5 divided by
27.5 minus what?
2? 20.5? Or is it?
Well,
Sorry.
yeah, that would be the whole range. And I guess there's also the chance, what if this distance was not the same as this distance? What if it was like 22 to 27.5? So sometimes that can't happen. And you'd have to have some sort of like hybrid problem. Because I was finding how many units away was this, and it was 3.5 units away. And then I wanted to divide by 2, so it tells me how many standard deviations away it is, not just in terms of units. And now that I know the t value is 1.75, I believe that's the same in this direction, right? If I do 24 minus 20.5 divided by 2, that is also the same value. So that's why I can just use one t value. I don't have to have one of those.
Plus or minus.
Yeah, so 1.75 standard deviations is what I'm going to look up. So I know a t value here. I'm going to go down to like 1.7. And you could use 1.8 if you wanted. Now, what I want to point out is it is not going to be the average of those two numbers. It is the midpoint of 1.7 and 1.8, but it will not be the midpoint of that. And the reason that's true is this curve, all right, 1.8 and 1.7, this is not like... That little space between those is not evenly distributed. All right, it's not like a flat line across. It's like a curve across. So if I find the midpoint, there's more to the left than there is to the right of that little slice. So that's why I want to point out it's not the average of those two values. I might end up showing you today how to calculate the exact value on your calculator instead of having to use a table. But I think the table strategy works pretty good. Yeah. I like it. I like it. So let's see. So what was I doing? I think I can paste that. So when t is 1.75, my p-value is, I don't know, 92. I'm fine if like you average it somehow, or even though it's not technically the average, right? You could kind of just say 92% or something like that. Whatever you want to say, right? And What did they actually ask for?
That was it.
All right, they said 92.9, so they actually straight up chose this. And actually, they chose even something bigger than that. Yeah, theirs is just flat out wrong. Jeez, Libro. Come on, bro. Libro. Psh. I don't know what they're thinking. So 92% of the data lies between those values. All right, so good stuff. Good stuff. Let me actually see if I could look that up real quick. Let's see it. Oh, actually, wait. Better yet, watch this. What? I finally got this working the other day. Isn't that great? Good stuff. Let's see. Yeah, I know, but I had to call. I'm not trying to give TI a bad review or anything, but I was on the phone with them for an hour yesterday to get this up and running again. Yeah. But they helped me out. They were very friendly. Thank you, TI. Shout out to you, whatever your name was, lady. But hey, now she's famous on the internet.
That's
Just like
too
that.
bad, lady.
Just like that. Yeah, TI lady. Texan woman. So let's see. So what you can do, watch this. If I hit second and go hit this vars button, there's normal PDF, normal CDF. If I go to normal CDF, oh, it's not doing the thing I did yesterday. Oh, shoot.
Whoops.
I think I need to do negative 1.75, comma, I was used to something slightly different than this, the format. And then 1 and close parentheses. Nope, that didn't work. Oh well. Let me see if I remember. I thought it was CDF that I wanted. Yeah. Okay, all right. I just don't remember what all the inputs were. So guys, if I enter negative 1.75 as the lower limit and positive 1.75 as the upper limit, mu is 0. I think we'll talk about mu later. Actually, wait, mu is just the mean in this case, but that technically doesn't matter. And it's going to calculate this out for us, and I got 91.988.
So that's how they got.
Well, that's 92. Oh, buddy.
Yeah, so about
That's how they got
92%.
92.9. That's
Right.
how they did it.
Yeah, so let me actually see if I was here. I wonder if it was mode. Math print classic.
Cold.
Anyways,
Red water.
yeah. Yeah, let me do second entry. So if I entered 0 was the mean and comma 1 is the standard deviation, it will actually give me the range. So there's that number there. So I just want to point out your calculators can give you something more accurate than our list. And actually, I generated this list using Excel. So your calculator, it's as though they programmed it planning on people needing to look stuff up on these tables, and they programmed like a whole bunch of data on it for us. And isn't that great? They planned ahead, maybe. Jeez, man, come on. You can't shut off your phone? Come on, man. So let's see. So, gentlemen, P is 91.988% then is what we'd have. Something like
Which
that.
then you just round it, and that's 92.
Well, yeah, but if I wanted more decimals and more accuracy.
92, and then
Because what if this was like
8,
data
9.
regarding like a billion people, right? I'd be off by a lot of people if I didn't have more decimals, right? I mean, in this case, it's only 500, but still makes a difference. Let's see. Let's look at what's the next problem here. Part C, the one that you guys were interested in. Find the interval about the mean that includes 50% of the data. This sounds good to me. So let's see. So I know that P is 50%. Are you writing any of this down, friend? It doesn't look like you are. Your notebook's on the ground. Seriously, man? Seriously? Oh, settle down, Libro.
Oh, oops.
So anyways,
Friendo.
gentlemen, please. So this time I know the p-value, so I go down to 5, and I want a t-value in this case, not a z-value. Actually, check out what is going on with this z-value.
I don't like that.
What does that mean?
But there's no way.
16 zeros.
That's
That is computer speak for 0. right? That's point, and then 15 zeros, and then 139214. That's 0, is what we'll call that, right? And that's actually talking about the 50th percentile, right? The point at which 50% of your data is beneath should be right at the, right, 0 standard deviations above the mean, right? Something like that. So anyway, so I end up getting this guy. So make sure you're writing this down, write corrections here, guys. Right, you know what I'm saying? It'd be good to learn this stuff, so that way on the test will be awesome. Right, anybody? 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 So T is 0.674. And now what did they ask? They wanted the interval about the mean. So this T value is in standard deviations, right? So I want to figure out how many units is that. So if that's in standard deviations, what would I do to that?
So the P is the percent.
Do you multiply both sides?
If I multiply that T value by sigma, that will convert it to units. All right? So my X bar was, what was it, 20 on this, 24? Yeah. Plus or minus 0.674 times the standard deviation, I believe, was 2. Right? Is that what they said originally? Yep. So let's do this out. So I'm going to do 24 plus 0.674 times 2, enter, and I get 25.348. So that's the upper bound. And the lower bound I would get by doing, I would enter that again and then just subtract that value from 24. So, nope, yep, there we go. Hit enter and I get 22.652. So that is the range for which I have 50% of the data represented. Or in this case, I would expect 250 data values to lie between those 2 points. All right. So let's consider D real quick, and I think we might have to call it after that. Find the interval about the mean, so it's another t-value situation. That includes 95% of the
Just
data.
do the exact same thing.
Exactly. So I'm going to have, I know this time P is 95%.
So
I'm looking for my t-value.
And you go to 90.
And I got the blurries. And I believe it's going to be 1.9599. That's all right. That was like a duet there. That was amazing.
Gus TT Showbiz.
That's right. So I look up my t-value. And 1.959, well, oh man, wherever I round, this is going to be ugly. 1.96, I'll say, is not measured in units. That is measured in standard deviations. So what am I going to do? I'm going to take 24. I'm going to add and subtract 1.96 times 2. Right? Multiplying that by the number of units in a single standard deviation will convert this all to units. And if I add those units to my mean, it'll give me my upper bound. If I subtract, it'll give me my lower bound. So I will have 24 plus 1.96 because it's more than one standard deviation.
Times 2 equals
And I get 2792. And then the lower bound, I'll just do the old second entry.
Could have saved more time if you just entered it
Would I have 20.08?
again. Maybe.
Right? So now there's the range of which 95% of my data would lie. Right? And now these sort of statistics is how people can calculate all sorts of facts about populations and quality control, right? Things like that. So like, for instance, what if these numbers were, what Well, I'll wait until today's lesson, actually. Tell you what, I'll wait until today's. No. So I think we're good for this, and then we'll take a look at today's lesson in just a moment. Adios.